Hello 8th grade, I'm Mr. Rogers and you're watching the video lecture for our next big idea here, which is how do we read chemical formulas. So now we know about atoms, we know about molecules a little bit here, and now we're trying to, again, understand our learning target here is to be able to develop a complete model of simple molecules. So to do that, we have to know if we see a formula, we can look at that and pick apart the individual parts so we can see what it is. So these are chemical formulas. This is how we read these different molecules when they put them together. The formula is kind of the shorthand way of putting together what that looks like. So a chemical formula, kind of two big ideas. It's a representation of a substance using symbols for its element, a shorthand way to represent an element, or a compound. Remember that image. So we have water, we have sugar, a little bigger there, and things like salt also. So how do we read? What does this mean? When we say water and H2O, what does that mean? We say sugar and we say C6H12O6. What does that mean? So what is that chemical formula telling us? We got to understand what that is so we can start picking it apart. So with elements, all these elements, remember our periodic table on my wall there. Each element is represented by a capital letter. So that symbol then could have one capital letter, maybe like a lowercase letter for the second one. So things like this. So here's rust. So Fe2O3. So we can see on there that iron is Fe. It's one element. Then we have oxygen is the second one. That's its own element as well. So there's two different types of atoms, two different elements in rust here, Fe2O3. So how do we count these up now? We have different types of atoms. How do I know what we're looking at here? So identify the number of elements in the chemical formula is our goal. So when we do this, we have 2HCO3. What does that mean? So I look at my capital letters. So I've got 1, 2, 3. So the number of elements or types of atoms is going to be 3. If I have just O2, there's just one capital letter, that's one type of atom or one type of element. So this one, look at this one. NaCH, NHCO2, so you have 3. So I have 1, 2, 3, 4 capital letters. I have 4 types of elements there. So 4CO2, C and O. So I have 2 for that one. So these molecules, when we write these formulas, a lot of times you see a big number in front of the formula. This is a coefficient. You write that in front. That tells you how many molecules you have. So it's at the beginning. So there's no coefficient. We assume it's 1. So if we have 3 Fe2O3, that means here I have 3 molecules of Fe2O3. So how do we count these up? Here's kind of the big idea. So in our chemical formula, how many molecules do I have? There's a 2 in front, so I'm going to have 2 there. There's a 6 in front, so I've got 6. There's a 3 way out in front here, so I've got 3. There's 4 right there, so I've got 4 different molecules of that one. So atoms. When we do this, each individual atom is represented by that subscript. It's kind of off to the lower right corner of the symbol for the element there. So we kind of add those up to get our chemical formula. So then we multiply that number at the lower right by that number out in front, and that tells us how many total atoms we've got. I know this is a lot of stuff we're going through right now. So I look at this. Here's a really good example to write down and kind of really break down this. So I have 3 Fe2O3. So what I want to know is this tells me I have 2 iron atoms, and this tells me I have 3 oxygen atoms in every molecule. So there's 5 atoms in one molecule. So this out here tells me there's 3 separate ones. So multiply my total for 1 times my subscript. So 3 times 5 gives me 15 total atoms in this chemical formula here. All right, so we'll do a couple of these, and this will be the last thing we do for the day. So we have 2HCO3. So I'm looking for the total number of atoms. So there's 1 there, there's 2 there, and this number here, 3, tells me there's 3 oxygen. So I have 1, 2, then 3, 4, 5. So I got 5 atoms, and I look at that coefficient out in front, there's 2. So 2 times 5 gives me 10. Another example, here's my oxygen again. So I've got just one element, just that oxygen, and there's 2 of them, times 6 gives me 12. Well, here's the big one. So I've got 1 capital letter, then there's a 2 right there. There's no number right there, so I assume this whole Na is 1 plus 2 plus 3 plus 2. So that's going to give me a total of, let's see, so 3, 6, 8 total times 3 gives me 24. 8 times 3 is 24. And our final example here, we have C, carbon, there's just 1, because there's nothing there, so we assume it's 1. And then there's 2, so there's 3 total atoms. 3 times 4 gives me 12. So this is kind of an example of how we work through counting these total number of atoms. So we need to know this. We get to be able to build a molecule. If you see that formula, you can break that down into, divide it into an actual molecule and draw that out. So 8th grade, we are going to stop here. I thank you guys for watching. We went through a lot of stuff really quickly. I'd probably rewatch this, kind of watch how I counted the atoms and counted the different molecules and what those things mean. So 8th grade, I thank you guys for watching, and we will see you along the way.